I'll present introduction, related work, method, result, and conclusion sequentially. First, let's take a look at introduction. Deep learning technology has introduced to improve the quality of detection. However, the available data is highly imbalanced toward normality. Scholars try to use the anomaly detection to solve this problem. Therefore, GAN-Anomaly, one of the best GAN-based anomaly detection models, has drawn great attention and has an impressive capability in the handwriting digit recognition dataset. However, it is necessary to verify the industrial inspection capability of the model. In this paper, the public industrial inspection dataset MVTec AD and the wood sample from actual production line were used to examine the performance of GAN-Anomaly. Additionally, different definitions of residual scores were used to improve the ability of GAN-Anomaly. Next, let's take a look at related work. Generative Adversarial network, as known as GAN, is an unsupervised learning neural network. This network learns to generate images with a similar probability distribution as the training data. GAN generally have a generator and a discriminator. They compete with each other during the training process. Then we can use generator to create similar image. The lack of detect sample is a big issue in the industry inspection. Therefore, anomaly detection has become a significant method. It detects the sample by finding the difference between the sample and the standard normal sample. It only needs normal sample during training process. GAN-based anomaly detection is an anomaly detection method which designed by GAN. GAN-Anomaly, which is one of the best GAN-based anomaly detection in recent years, consists of a generator, a discriminator, and an encoder. By training the normal data, the generator can create the image is similar to normal image. Then, the original image and the fake image would input to the discriminator for feature extraction. And the two images are encoded to two vectors. They define the L1 distance of the two vectors as the residual score. A higher residual score indicates that the sample is abnormal. Next, let's take a look at method. Because GAN-Anomaly may have different performance in different situations, and the detection capability of GAN-Anomaly in industrial inspection has not been verified. In addition, the defective samples are unintentionally mixed into training data, which may cause the decrease in detection capability of the model. The goal of this paper are verifying the industrial detection capability of GAN-Anomaly, including improving the performance on samples and investigating the problem of mixing abnormal data into normal training data. The first data used in this paper is MVTec AD. It's an anomaly detection dataset, comprised 15 categories. We choose 12 categories with 3 channels to test the proposed method. Here are the categories of MVTec AD, including carpet, grid, data, tile, wood, bottle, cable, capsule, hazelnut, metal nut, peel, screw, toothbrush, transistor, and zipper. The second dataset used in this paper is wood dataset. It's an anomaly detection dataset about wood. These are the labels of the wood dataset: contents, normal, chalk, whole, black, not, and others. The labels except normal are all anomaly. In this paper, the detection capability of GAN-Anomaly has improved through the different definition of residual scores. The first one is L1 distance with 2 vectors, which is shown above. The second one is L2 distance with 2 vectors, and the third is L1 distance with 2 images. The experiment was carried out by the equipment shown above, and under the deep learning framework of Keras. The loss was consisting of adversarial loss, contextual loss, and latent loss, and training step was set to 20,000 for training, and learning rate was set to 0.001. The performance was evaluated by the area under the curve, AUC. When AUC is closer to 1, it means that its detected capability is better. Next, let's take a look at result. Here is the result of verification of the detection capability with MVTec AD. It can be observed that this model has a large range in detection capability in industrial detection. On the other hand, in the case where a small amount of detective products were mixed into the training data, the impact on AUC was... What?
No, sorry, please continue.
Okay. The impact on AUC was marginal. The reason is that the difference between the defective image and the good image was not very large, and the probability distribution of the entire image was still similar. Therefore, GAN anomaly has higher resistance to such noise in the training data. Here is the result of verification of improvement of the detection capability. This page shows the categories with higher AUC detected by using distance 3, including pill, bottle, and hazelnut category, etc. Most of them are object samples. The reason is the generator was able to reconstruct the object sample much better than the texture samples, with no variation in object sample. In the case of detecting object sample, feature extraction made data loss, resulting in a decrease in AUC. Oh, oops! I just I say the wrong. Oh, this page. Okay. Oh, this page shows the higher AUC detected by using distance 1, including carpet, data, tile, etc. Because such as the texture samples, because texture sample is more complex and generator cannot reconstruct it very well. So if we use feature extractor in this samples, the AUC will be increased. This page shows the AUC of the wood data set. It can be seen that GAN anomaly performed better by using distance 1 than distance 3. This was because the wood detection sample of the actual production line were texture sample, which increased the detection ability in feature extraction. Next, let's take a look at conclusion. There are 3 important conclusions of this paper. First, GAN anomaly has a great anti-noise ability. Second, using distance 3 as a residual score to detect object sample was better than using the original residual score definition of GAN anomaly. Third, GAN anomaly has a great performance for the wood sample of the actual production line. Okay, thank you for your attention.
Thank you very much, Dr. Tang. Is there any question from the Dr. Tang?